of the data through different means. Like for example, we want the data to be not disclosed to unauthorized users, and we want the data to be secure so that an unauthorized user cannot access that, and that the data which is transmitted from user A to user B, that would be difficult for an intruder or an attacker to analyze that data, to see that data. And we want the data to be sent it to other user by a legitimate user, means the intruder cannot masquerade or can have an access of other system, legitimate users address, for example, or IP or ID, and then he used that IP or ID to send the message or send the data to other user. So we also want to protect that, and we also want to protect the data from different modifications. That data should not be modified by the unauthorized user. And in this way we can also have an access of provide the availability of the different services which are necessary to the users. And the intruder or the attacker may try to uh, to block those services to be accessed by the user. So we want to protect the system from such type of attacks. As we have discussed, that uh, there are uh, there are different methods to protect the system from disclosure. Like for example, uh, we can encrypt the data to provide the secrecy of the data, to hide the data from unauthorized users. So for encryption, we have used different methods. Like for example, we have the symmetric encryption methods, we have the asymmetric encryption methods. In symmetric encryption methods, we were using the same keys on both sender end and on the receiver end. And in the asymmetric encryption, we were using different keys for the private key, and a different key uh, for other user. So the private key, if both can be used for the different purposes. Like for example, if we are using the private key for encryption, and the public key for decryption, that is used for authentication of the data, that the user is authenticated user. Or for example, if we are using the public key for encryption and the private key for decryption, that means we are encrypting the data. So in this way we can make the data secure, or we make the data secure so that the unauthorized user cannot read their data, cannot access their data without a proper method or without having a proper key. And then we discuss about different other methods, like for example, message authentication code and the hash function. Like as we discussed, that the message authentication code and the hash function, they are used to identify the modification in the data, that if either the data has been modified by the intruder or not, or the data has been coming from legitimate user or not. So for that, we were using the message authentication code. In the message authentication code, as we know that we are using we are creating some code. So on the basis of the message, we create some code, and then we attach that code to the message. And then at the receiver end, we compare that code with the code which is created again at the receiver end. When that is same code which is received by the receiver, it that means the data has not been modified. So this is a way of knowing that how the data is either the data is being modified or not. So with the help of the message authentication code or make code, we can identify that we can know that that message has not been modified. So these are this is the way to know. And then uh, we have how we create the message authentication code. We apply some method on the message, and then it will create a message authentication code. So when we apply some method, or when we encrypt the message with the private key, that means also it provides the authentication to the data. So in this way, we can also provide the authentication of the data, as well as the, you can say, integrity to the data with the help of message authentication code. And then we discuss about some other method for providing integrity, that is, for example, hash function. So hash function is used uh, to apply on the message. For example, it is using some function, and when the some function is applied on a message, that creates you can say some output from that. So that is actually called as a message digest. So that message digest is actually that is used to know the integrity of the message. For example, if the message the hash function is applied on the message, and it creates a message digest from that. Then, for example, at the receiver end, it is received by the receiver. Then again, that message digest or message, the output that is produced from the hash function is compared with the original message digest, which has been received by the receiver. So after that, when it is compared with the original message, so then if it is the same message, that means the message has not been modified. So in this way, we can know that how the message is either the message has been modified or not. So through these methods, so this the we have also discussed different methods of the hash function, like if the hash function is applied on a message. So there are the different requirements for the hash function. For example, there is a hash function which is applied on a message and that create a message digest, for example. So either we can create recreate the message from that message code or not. So if that's the situation, if we cannot create a message from a message digest, so this is called as a one-way property. Or for example, if we have the different messages, and if they are producing the same message code, so that means that is actually here the intruder can apply this technique, that he can recreate the same code from other message. So in this way, it is a type of collision. So if we are having the different messages, and they use a different message digest code, so that is called a strong collision resistance. So we have different properties of the hash functions. Either we can create the message from the message digest, or for example not. If we cannot create a message from the hash function or hash message digest, so that means it's a one-way property. If we can create the message code from the different messages, so that means same code is created, that means it's a weak collision resistance. If it is a different code is created, that means it's a strong collision resistance. Because in this way, the intruder or the attacker cannot try to create the same message from other code. So if he cannot create the same message code from other code, that means he cannot modify the message, or he cannot change the message. So in this way, we can apply different properties of the hash function. And then we have we discuss about different types of attacks, like for example, which can be applied on the hash function, like for example birthday attack. So it can apply different messages and create a code which is actually same code which is which is created from the different messages. So in this way, he uses different messages to create the same code to which is in the original message. So in this way, this type of method is also, we say that it's a type of brute force search that is applied on some message to create the same code that is that of the original message. So this type of attack is actually called the birthday attack. And then we can also apply the message hash function on a block of code. Like for example, it could be a 60-bit size or some other length, so we can also apply hash function on that. So there's a possibility that if we are applying the hash function, there could be the main and middle, or the intruder will try to modify that data. So he can apply different methods, or he can recreate the same message code from the message that he contains. And then if he creates the same message code from that, then he can send that his message to the you can say other user. Then he can also masquerade that he's a legitimate user. So in this way, he can apply these different methods to modify the data using different attacks like birthday attacks or some other attacks. Or for example, he can also apply some brute force search methods uh, to uh, to attack on the data to you can say uh, exploit the integrity of the data. So he apply some methods like as we discussed, by recreating the same message code from the message and apply the age function. If he can create the same message code, then he can be able to modify the message. He can also send its own message, or he can also modify the message to be sent it to other user. So in this way, he can apply these techniques to provide the uh, uh, to exploit the integrity of the data. So when he applies that to the data, then the data can be modified. Now we discuss about some other methods like that of the hash function. Now we further discuss about some algorithms like hash algorithms, which can be used for making the data secure, which can maintain the integrity of the data. Now, how we can maintain the integrity of the data by applying these methods. Like for example, we have different types of hash functions and which apply different algorithms. Like for example, they can use a DAS algorithm, they can use a AES algorithm, and MD4, MD5, SH1, and write MD160. So these are the different algorithms which are called hash algorithms, which can be applied on some data, or which can be applied on a block of data. So they are actually used to maintain the integrity of the data. So what the integrity that means here, the intruder, the attacker cannot modify the data, or he cannot change the data. So that means the integrity can be obtained with the help of maintaining the data, so that that could not be changed by the intruder, or that could not be changed by the attacker. For example, there are the different methods of hash functions. Like for example, there's a MD5. It is designed by the Ronald Rivest, and that is based on the RAC algorithm, and it is a latest version of the MD2 and MD4, and it produces about 128-bit value, hash value, or we can say message digest from the message. and it was recently it can be used a brute force attack or some other types of attack to be applied on the MD5 uh, to to exploit the integrity of the data. So we will discuss that how the MD5 provides the integrity to the data and how the MD5 works, what is the what's the algorithm, and what are the different steps which are applied, which are used by the MD5 algorithm. Like for example, if there's a message of for example 512 bits length, and it's you can say padding of 448, and for example the message that is padded or that is added to the original message, that is used for the different purpose. For example, it can be used for some error, checking some error in the data, or for example to check if particular data is being modified or not. So in this way we can use the MD5 methods, which can be applied, or for example if there's a 512-bit block of data, or for example 16 words which are used in the message, and then the MD5 function is applied on that message, and then it will produce some hash value, and that hash value, or we can say message digest, which is received by the receiver with the message, and then in the same way it is recreated by the receiver. And when it is recreated by the receiver, if it is producing the same message that of the original message, for example, that means the data has not been modified, or the data has not been changed. So that's why we say that it is actually the method that is used to be applied on a message to provide the integrity of the data. And then we discuss that how that the MD5 works. For example, this figure explain further MD5 message. So there's a message here, and there's a you can say padding that is added to the message to check for some errors into the data, and this field defines the size of the length of the particular message. For example, there are the different messages are used here. That is a, for example, 512 bits from left side, 512 bits from the right side. So they applied it uses a MD5 function on 512 bits of the message, and when it is applied on some on that, it produces some hash value from that, or message digest from that, and that hash value which is created from a message digest that is, for example, of 128 bit size or 128 bit length. So in this way the MD5 algorithm can be applied on the message. For example, the message length is 512 bit, and it produces the output from that, that is a hash value, and that is a 128 bit value. So at the receiver end, both the messages, both the message as well as the hash value that is received by the receiver, and the receiver again reproduce the message from that hash function, or MD5 hash function, for example here. So when it produces same hash value of 128 bit as that is received by the receiver, that means it is actually the message has not been modified. So in this way, this algorithm can be used to be applied on some message. So actually, this type of message, which has been received. So in this, the MD5 algorithm can also use uh, the algorithm for the semantic encryption. Like it can use a DES algorithm, or it can use a AES algorithm for encryption. So in this way, it applies the integrity to the data. So once it is applied to the message, so we can have the integrity into the data, and we can check that either particular message which has been received, that has been modified or not. So in this way, we can recalculate the hash function through the MD5 function, and once it's the same, when it is the same as that of the message that is received, or is that of the code, or is that of the value which is received by the receiver, that means it is a the message has not been modified, and it maintains the integrity into the data. So the hash function or MD5 function also applies the compression into the data. For example, it uses 16 different steps to be applied to on the data to provide the compression as well. So this is actually the formula that is used to be applied to produce some compression on the data. So how the compression is used by the MD5 algorithm. So this figure further explain that how different functions are used uh, for to create or for to compress the data. For example, there are the different messages A, B, C, and D. So it calculates the greatest common divisor for B, C, and D, and then it uh, it uh, it adds to the A. For example, it produces it uses some function. For example, it could be exclusive OR function or some other function, and that is applied, for example, with the message A, and then again it applies the same thing with the message that is produced by this output, or the output from that function. So it again uses that, and in this way it applies about 16 times. So it applies 16 rounds for that. And then after creating these messages, then it permutes the messages so that, for example, if there's a message A that is permuted with the message B, for example, if there's a message B that is, for example, permuted with the message C. So if there's a message D that is permuted with a message A. So in this way, after applying different functions, so it also permutes the data, or changes the data, for example, exchanges the data between different parts of the messages. So when it applies these different methods, then it can compress the data to the size that can be further reduced. So in this way, the MD5 function, along with providing the integrity to the data, along with providing you can say the security function, that is a means if any data has been modified, that it can detect that. So it also provides some compression methods as well, so that the data which has been sent it, if it is a large in size, so it can be reduced and send it to other data, other user. So we have different methods which can be applied for the MD5 as we discussed. So MD5 function is a function that is used for the integrity, and which is like a hash function, and it produces hash value. So it is used to be applied on a message, and when it is applied on the message, then it produces the value which is you can say attached with the message when it is received by the receiver. Then the message calculates that hash value. If it is if it is the same that of received, that means the message has not been modified. So in this way, the MD5 function works. So it applies this integrity to the data. So if you have any question up to now, then you can ask. Have any question? Do you have any question? Okay, now we have some other version of MD5. So there, before that, there's another. Before that, there was another uh, algorithm from MD. So that is actually MD4 algorithm, and that is also producing 128-bit hash value, and it uses about 3 rounds and uses 16 steps, which we have discussed in MD5 as well, that it applies different functions on the message, and it uses that functions in about 16 different steps, and then it permutes the message between different parts of the messages. So it is also used by the MD4 function. So it uses that to apply the comparison of the data, to apply the integrity into the data. For example, we have uh, now uh, what's you can say what's the difference between uh, other hash functions and the MD5 function. So the MD5 function is depends on the messages which are in the message, for example, and it also provides a good security as compared to other hash function values, and it uses as as we discussed, it uses different round functions, and it uses different steps which are applied on the data. When different steps or different hash functions are applied on the data, it makes the data more secure, is because some other functions, as we discussed before that, so it were applied on a message and then it produces a hash value. So this algorithm is using the different other steps as well. So when different other steps are applied, for example, as we discussed, 16 different round functions are applied, and each function is actually adding some value to the message. And when it after 16 different steps, it applies different other permutations as well. So in this way, it makes the data more secure, and it makes more data more difficult for the intruder to modify that data or to create the same hash value or same message digest from that value, so that the intruder use that, and then he can apply some integrity, he can set threats on the data or some integrity attacks on the data. And then we have some other functions that is used for the hash value, that is hash, that is also called as a hash algorithm, which is a secure hash algorithm. Like for example, Lecture1 algorithm, which is applied on the data to provide the integrity of the data. For example, it is applied on the data, and it also produces a hash value that is of the 160-bit hash value, and it is generally preferred hash function, and it is also mostly used by this some you can say application. Most of the applications uses the secure hash function value. So it works like same as that of the as we have discussed different steps in the MD5 as well. So it actually there's a message, and that message actually